This is lesson 6-8, and we'll be doing the warm-up first. Number 1, write the explicit formula for each sequence, and here's a reminder of how the explicit formulas look. This one's for arithmetic, and this one's for geometric. So number 1, we have to first decide what kind of sequence it is. So if I go from 4 to -3, -3 to -10, and -10 to -7, I see that I'm subtracting I'm subtracting 7, so I'm adding -7, so that's my D. I can see that my a sub 1 equals 4, and so I'm going to write my equation. A sub n is equal to a sub 1 plus D times n minus 1, and that's my equation. That's the explicit formula. Okay, for number 2, looking at the pattern, it's 12 to 6, and I can see that that's a difference of 6, and then 6 to 3, that's not a difference of 6, so I can tell right away that this one is not arithmetic. So a really good way to tell if it's geometric, I know that if it's geometric, I would have to do 12 times something is equal to 6, and so if I just wrote it like a little equation, that means that x is equal to 6 divided by 12, which is 1/2. So if this is geometric, which I'm not saying it is, but if it's geometric, I'm going to have to multiply by 1/2. So if I do 12 times 1/2, I get 6. So let's see if that works for 6. If I do 6 times 1/2, I get 3. If I do 3 times 1/2, I get 1.5. And so this is working. So my sequence here is a geometric sequence. So I'm going to write that r is equal to 1/2. You can write 0.5 if you want. And so my a sub 1 is 12, so I'm going to write a sub n is equal to a sub 1, which is 12, times 1/2 to the n minus 1 power. And so that's my explicit formula. Okay, number 3, from 5 to 20, that's 15, and from 20 to 80 is definitely not 15. So I'm back to, is this a geometric sequence? So I'm going to use the same strategy that I did last time. So I'm going to say 5 times something is equal to 20, and so that would have to be 4. So if I do 5 times 4 is 20, what about 20 times 4? That's 80. And 80 times 4 is 320. And so this is a geometric sequence. And so I'm going to say r is equal to 4, and a sub 1 is equal to 5, so I'm going to write a sub n is equal to 5 times 4 to the n minus 1 power. Okay, number 4, 14.8 to 16.5. And so I can look for a difference there. If I do 16.5 minus 14.8, and that's 1.7. And so if I do, that means that if I do 14.8 plus 1.7, I get 16.5. So let's see if it keeps working. 16.5 plus 1.7, is that equal to 18.2? And so the answer is yes, it is equal to 18.2. And so the last one I'm going to check is 18.2 plus 1.7, and that is equal to, and I check, and it is 19.9. So that is my pattern. So my 1.7 is going to be my common difference. And you can, all that stuff that I just had written there, you can just do that on your calculator and see, what the differences are, but then write it down. Difference is equal to 1.7. And my a sub 1 is 14.8, so I'm using the arithmetic one. So a sub n is equal to a sub 1 plus, and then the difference is 1.7 times n minus 1. Oops. Okay. Okay, so a geometric sequence is defined what we call recursively by a sub 2, a sub n is equal to a sub n minus 1 times 4, and n is greater than or equal to 2. So the first thing I'm going to do is write the first 5 terms. So I know the first term is -2. The formula right here, it tells me that what I'm doing is I'm going to be multiplying by 4 every time. So if I do -2 times 4, I get -8. And if I do -8 times 4, I get -32. And if I do -32 times 4, I get -128. And then if I do that times 4, I get negative 512. So those are the first 5 terms of my sequence. Now that I have that, I'm going to write the explicit form. So that's what we did just right up above. So since this is a geometric sequence, I'm going to say a sub n is equal to a sub 1 times 4 to the n minus 1 power. And that's it. Then to find the 10th term, I'm going to say a sub 10, because I'm finding the 10th term, equals negative 2 times 4 to the 10 minus 1 power. And I'm going to put that in my calculator. I'll put in negative 2 times 4 to the 9th power. And that gives me, let me make some space here, that gives me negative 524,288. And that's the 10th term of my sequence. Okay, number 6, an arithmetic sequence is defined by a sub 1 is 15. That means the first term is 15. And then a sub 1 or a sub n equals a sub n minus 1 minus 4. So that tells me that every time I'm going to be subtracting 4. So if I do 15 minus 4, I get 11. And 11 minus 4 is 7. 7 minus 4 is 3. And 3 minus 4 is negative 1. And there's my first 5 terms. And so I'm going to put dot, dot, dot. Okay, the explicit formula, again from up above, we're going to say a sub n is equal to a sub 1 and then plus d. So in this case, it's plus a negative 4. So I'm just going to write minus 4. Times n minus 1. And then to find the 45th term, I'll write a sub 45 is equal to 15 minus 4 times 45 minus 1. And then I'll put that on in my calculator. And I will get negative 161. And that is what the 45th term is. This is Secondary 1 Math, Lesson 6-8. Okay, in this lesson we are going to use our formulas to find other terms that we're missing. So just as a review, the explicit formula for arithmetic and geometric sequences is written right there. So the directions for here, it says given a specific term and the common difference d, or the constant ratio r, use the explicit formula to solve for a sub 1. So we're going to look for the first term, even though that's not what we have. So for number 1, it says a sub 23 is equal to negative 14. D is equal to negative 5. So that's a clue right there that we're talking about an arithmetic sequence. So that tells me that I need the equation a sub n is equal to a sub 1 plus d times n minus 1. That's the one that I'm going to use. So what I'm supposed to find here is what is a sub 1. So I don't know this right there, but I do know some other things. I know that a sub 23 is equal to negative 14. So that means that n is equal to 23. And a sub 23 is negative 14. So if I write a sub 23 equals a sub 1 plus, I know d is negative 5, and n is 23. I also know that a sub 23 is negative 14, so I'm just going to come over here and I'm going to write negative 14. And now if you look at what we've just got an equation to solve. So I'm going to simplify it. A sub 1 I still don't know. So negative 14 is equal to a sub 1 minus 110. I'm going to add 110 to both sides. And so a sub 1 equals 96. And so that's the first term of the sequence. So what that means is it means that if I started with 96 and I subtracted 5 every time, and I subtracted 5, and I subtracted 5, and I kept on going, when I got to my 23rd term, I would be at negative 14. And that's what that means. Okay, for number 2, it tells us that a sub 18 equals 12, so that means that my n is going to equal 18. D is equal to negative 1, so again I'm going to be using the arithmetic sequence. So I'm going to write a sub n equals a sub 1 plus d times n minus 1, and then what I'm going to do is I'm going to go through and replace some things. So my a sub n is going to be a sub 18. And I don't know a sub 1, that's what I'm trying to find. D is negative 1, and then n is my 18. I also know that a sub 18, I know what that's equal to, so that's equal to 12. So the point is we're trying to get as rid of many variables as we can. So now if we solve that, 18 minus 1 is 17, so I'm going to have a sub 1 minus 1 times 17, and so that's going to be 12 equals a sub 1 minus 17. I'm going to add 17 and add 17, and so that's going to be 29 is equal to a sub 1. And that's my first term of my sequence. So again, if I started at 29 and I subtracted 1, if I went 18 times, I would be down at 12. Okay, for number 3, notice the difference. It tells us the r is equal to 2, so that means I'm talking about a geometric sequence. And so I'm going to start with a sub 14 is equal to a sub 1, which I don't know, times r, to the n minus 1. My n in this case is 14, so I'm going to say 14 minus 1. Now if you want to just write 13, that's fine. With this one, we have to be a little bit more careful because of order of operations. 2 to the 13th power is a pretty big number, and I'm not going to write out what that is, but I do know that a sub 1 times 2 to the 13, to get that a sub 1 by itself, I'm going to have to divide by 2 to the 13th power. I will let my calculator worry about the big numbers there. One thing I also need to do is replace my a sub 14 with the number 384, and that's just because I don't want all these variables, and if I know what they are, then I'm going to replace them. So I'm going to divide both sides by 2 to the 13th power. So get your calculator and say 384 divided by 2 to the 13th power. You get 0.046875, and that's equal to a sub 1. So that means if I started with that really small number and I multiplied by 2 and I multiplied by 2 again and again and again, when I did that 14 times and got my 14th term, I would be at 384. Okay, number 4, again I have r, and so I'm going to be dealing with a geometric sequence, and so I'm going to write that down, and I want you to pause this video and see what you can do with that. See if you can find a sub 1. So we can go ahead and just write 34,992 for my a sub 8, and I don't know my a sub 1, that's what I'm looking for. My r is 3/4, and my r is going to be 8, so 8 minus 1 is 7. So when I go to solve this, I'm trying to get a sub 1 by itself, so I'm going to divide by 3/4 to the 7th power. Now write that down on your paper, but then get your calculator and you're going to type in 34992 divided by, parentheses, 3 divided by 4 to the 7th power. And then that way your calculator is going to see this part first, because order of operations, it'll do exponents first, and then it will take this and divide that. Okay, d is equal to 8, so you're going to be using arithmetic sequence, so pause the video and work on 5 and 6, and then we'll start this back up. Okay, so this is how you should have 5 set up. 450, that's my a sub 52, equals the first term, 8 times 52 minus 1. So 450 is equal to a sub 1 plus 8 times 51, and then 450 equals a sub 1 plus 408, and then we're going to subtract 408 from both sides, and that's that's going to be 42, and that's my first term. Okay, so for number 6, this one's geometric, and so if you haven't already set this up, then pause and see if you can set it up correctly. So you're going to have your answer, your a sub 10 right there, your a sub 1. You have to be paying attention to if you're doing arithmetic or geometric. And then this one you're going to say to the 10 minus 1 power. When you have something like this, you've got to remember that you're multiplying a sub 1 times something, so we're going to be dividing by 5 to the 9th power, because 10 minus 1 is 9. Divide both sides by 5 to the 9th power. So put that in your calculator, 9375 divided by 5 to the 9th power, and you get 0.0048, and that is your first term. Okay, at this point I'm just going to have you pause and work through the next couple, and then I'll show you what they are supposed to be, and I'll have it set up for you. Here's number 7. A sub 1 is 28, and so I've got the work out there for you so you can see how I set that up. Here's number 8. A sub 1 is equal to 1066, and so remember that this is an arithmetic sequence, so I set that up accordingly. So there's the work.